back to my YouTube channel Trouble Free. In this video, we are going to see the generation of rotating magnetic field within a machine in the subject of basic electrical engineering. So I have already explained you what DC machines are and what does a DC, why do you say it as a DC machine and what types of machines are there, how they work and all. So in this video, let's see how do you usually generate a rotating magnetic field within a machine. So to start with, like in all the three-phase machines means you'll have three phases, and you will be supplying the phase current with the help of windings, right? So in all the three-phase machines where you have the three windings distributed at an angle of 120 degrees, then a rotating magnetic field is generated inside that machine. How a rotating magnetic field is generated and what is the derivation of that, everything we will see in this video. Okay, so let's say you have three windings. Three phase means three windings, right? So these three windings should be at an angle of 120 degrees each. Here the angle between this and this is 120. Here the angle is again 120 degrees. Here also it is 120 degrees. So all three of them should be distributed, should be separated at an angle of 120 degrees. Then a rotating magnetic field will be generated within that machine. Let's see how this concept will work. Okay, and a good example for this is induction motor, three-phase induction motor. About three-phase induction motor we'll be learning in the next coming videos. Okay, so yeah, let's go. So this is how usually a machine is, right? Let's see, you know about this machine, the DC machine, or this is the three-phase motor. Basically this is the three-phase induction motor. So you're supplying three phases here. So in this you have this stator, the outside part, that is stationary part, and here you have the rotor, which is a rotating part. Okay, so here you will basically have three windings. So I'll show you in this picture, but this picture is this one. Okay, I know it is not good, but just try to adjust for now. Okay, let's see what will happen. So let us consider three windings. So three phase means three windings, right? So three phase means three windings, as I told you. So let us consider three windings. First one is R and R dash. R is one edge and R dash is the other edge of the winding. Y and Y dash, B and B dash. So we have three windings. Okay, and first let's try to put R. So let us say you're trying to have R winding here. Okay, R is here, R dash is here, and then 120 degrees I told, right? So probably Y will be here. Okay, so like we will have Y here and Y dash here, and then we have another winding at 120 degrees. Again we have B and B dash, so we'll have B here and B dash over here. Okay, so if you represent this as a as a phasor diagram, then how it will be? So first this is R, right? So this is R. Okay, this is R, and then you should connect Y at a 120 degrees from R, right? So that means here. Okay, and then you should connect B and B dash in such a way that it is 120 degrees from Y, or you can also say 240 degrees from R, anything you can say. Okay, in that way you have to connect. That means 120 degrees from Y means where? Here, right? So here, sorry. Okay, this is our B and B dash. So yeah, so now let's try to see how current will flow. So let us say this is one component of current, and this is how IY will come. Okay, first of all let us give names to them. This is R and this is R dash, right? So this will be Y and Y dash. So this will be B and this will be B dash. Okay, we've given names to the components, and and here this like this. So this is going to be your IB and your IY, and let's say this is going to be your IR. Okay, I don't know why it's getting blurred. Okay, that's fine. Now, so now all these together, this R, this B and this Y, all these are, sorry, this is three phase current, okay, all these are connected to a three phase current, and then we have the IB also here, okay, all these are connected there. Now, so whenever you have these three windings connected to the machine, okay, whenever you have three windings connected, what will happen? Automatically current will start. So AC current will start. AC current will start flowing in the machine, and those current components are nothing but for R it is IR, IY and IB. So these three are the current components we have for now. Okay, so for this, if you draw a waveform, it will be like this. Okay, don't get confused, I'll tell you. See, IR, it is starting from here at like here, and then you are starting IY here. This one is IY, right? And you're starting IB here. IB is, this one is IB. Okay, this one is IB. So you have three currents, and when you represent it in a waveform, you will be seeing this, right? So let us keep some points, like let us check at some point, like let us check at 0 degree angle. So let us mark some points and let us check how the current is going to be at that point. Like let us check how let's derive something at that point so that you will understand how a magnetic field is generated, how rotating magnetic field is generated. Okay, IR is what? In R, right? So whatever current is in R winding is IR. So IR, it will develop a flux in R phase. And how do you represent that flux? Using phi. Okay, so phi R will be something like phi max sine omega t. Okay, and what will be phi Y? Phi max sine omega t minus 120, because it is 120 degrees apart from R, right? And what will be your phi B? It will be like phi max sine omega t minus how much? 240. It is at 240 apart from this, right? So these three are your mathematical equations for the flux. Okay, now let us see how you will have this in a rotating, how this flux will be a rotating magnetic field. So a phasor representation will be simply like this, right? So this is your IR, this is your IY, and this is your IB, everything at 120 degrees apart from each other. Now what you will do is, you will calculate the resultant, where at, let us calculate the resultant at 0 crossover points. What do you mean by 0 crossover points? We just had a waveform, right? Let me get that. Yeah, we have this waveform, right? This is a 0, x is equal to 0, right? So in this waveform, at whatever points we are touching the x-axis, all those are called as the 0 crossover points. And let us see the resultant in the 0 crossover point. So this we are going to do using, like, let's say 3 cases maybe. So first one is going to be like omega t is equal to 0. Second is going to be omega t is equal to 60. And then we will do at 120 and also at 180, because at these points only it is touching the x-axis. If you go forward, you'll get so many, but for time being, let us do only these 4 cases, and then you will understand how it is a rotating magnetic field basically. Okay, so let us do case 1 now. So case 1 is what? Omega t is equal to 0 degrees. So if omega t is equal to 0 degrees, if you substitute that in this equation, what you will get? First, phi r is equal to phi m sine 0. What is sine 0? Sine 0 is 0. So this component will be 0. Okay. Next, phi y. Okay. So what will be phi y? Phi max sine 0 minus 120 is minus 120, right? So which will be minus 3 by 2 sine, minus 3 by 2 sine minus 1, sine minus 120 is minus 3 by 2 and phi max. Next, what will be your phi b component? It will be phi m sine 0 minus 240 is minus 240. So if you do sine of minus 240, what you will get? You will get root 3 by 2 phi m. Okay, so if you represent this in this phasor diagram again, first of all, what is R component? R component is 0. So you don't need any R component. So let us draw it in this way, imaginary. You don't need R component at all. Next, what is Y? Y is negative component. Usually what is Y? This one is Y. Negative Y means you should come in this way. Okay. Next, B. B is positive only. So you can directly come in this way. Okay. So this is the phasor representation of the flux. Since r component is 0, we are not drawing any r component, and since y component is in negative, you are drawing it opposite to the original one, and since b is positive itself, you are drawing it in the original direction only. Okay, so let us say if you imagine this as a parallelogram, okay, this is going to be the resultant, right? So exact middle one is going to be the resultant. So how do you calculate the resultant? In according to this, you have a formula. Phi resultant is equal to square root of phi b square plus phi y square minus 2 phi b phi y cos theta. Theta is nothing but here omega t, right? Or cos theta. Sorry, not omega t, actually theta. Theta is nothing but the angle between these two components. So what is the angle between these two components? Usually the angle between this one and this one is 120. So what will be the angle between this one and this one? Usually half of it, which is 60 degrees. Okay, so cos is going to be 60 degrees. If you substitute all the values, you will get like root 3 by 2 whole square is what? 3 by 4. Root 3 by 2 into root 3 by 2, how much? Just root 3 whole square divided by 4. Square root cancel, so it's 3 by 4. So 3 by 4 phi max square plus here also 3 by 4 phi max square. Why? Because here it will cancel out, right? I mean, though it is negative, you're doing square, so it will be 3 by 4 only, minus 2 into what is phi b? Root 3 by 2 phi m, and what is phi y? Minus root 3 by 2 phi m, and also cos 60. Okay, so this is going to be like, if you do the entire thing, you will get the answer as 3 by 2 phi max. Okay, so phi resultant is equal to how much? 3 by 2 phi max. This is the case 1. In case 1, when the omega t value is equal to 0, you got this one. Okay, now let's do case 2. Case 2 is what? If at all omega t is equal to 60 degrees. Okay, so 60 degrees means what you will get? Phi r is equal to, so omega t is 60 from these three equations. Okay, if you can remember these three, phi r is sine omega t. So phi r is equal to phi m sine 60. Okay, which is nothing but root 3 by 2 phi max. Okay, next phi y. Phi y, how much it will be? It will be phi max sine 60 minus 120, right? Which is minus 60, which is equal to minus 3 by 2 phi max. Okay, next phi y is equal phi b, phi m sine, so 60, right? 60 minus 240, how much? Minus 180, which is nothing but sine 180 is 0 basically. So you will get 0 component here. Okay, so now let us try to draw the phasor diagram again for this. So usually it is like this. This is R, this is Y, and this is B. Usually this is how it is. But here, since we have phi R positive itself, you can have the phi R component. Okay, and then phi Y is negative. So if this is Y, then what will be the negative Y? Straight opposite to this one. So here you get it. Okay, done. Now phi b, it is 0, so you don't have to consider this. Okay, you can just leave it. Now again, calculate the resultant, where you will have the resultant basically in the middle, exactly in the middle, right? Again, what will be the angle here? 60. So how, if you do this, like I mean, it's not in the exact shape, but if you do this in the exact shape, this is your resultant basically. Okay, this is in the exact middle. And how do you calculate the resultant now? Okay, before calculating resultant, let's do one thing. So here what happened in case 1, what happened? So basically you have one 0 component, one negative 3 by 2 phi m, one positive 3 by 2 phi m, and angle is same 60. So here also the same thing, right? One negative component you have, one positive component you have, one 0 component here. You're not even considering that 0 component. That's cool, fine. So again, angle is also 60. So I mean, everything is same, right? So in that case, what will be your resultant? Your phi resultant will be again 3 by 2 phi m only, because same scenario is repeating in case 1 and case 2, right? So let's see now. See, For example, here what you have, one zero component, one negative component, one positive component, and the angle is 60. And here also same scenario, one positive component, one negative component, one zero component, angle is 60. So you'll get the same answer. So here also phi resultant will be 3 by 2m. Okay, next. So let us consider next case, which is case 3. Okay, so in case 3, what is omega t? 120 degrees. So what will be IR? What is IR? Phi m sine omega t, right? Which means phi m sine 120. How much? Root 3 by 2 phi m. Next is IY, which is equal to phi m sine omega t minus 120, right? What is omega t? 120. 120 minus 120 is 0. So sine 0 is 0. So this component is blindly 0. So IB is equal to phi m sine 120 minus 240, which is minus 120. So which is equal to how much? Minus root 3 by 2 phi m. Okay. Now let us try to represent this in a phasor diagram again. In general, what is a phasor diagram? IR, IY, IB. Okay. Now, so you have the R component and it is positive. So it will be in this way. And then you have the Y component. No. So you don't have to consider the Y component at all. Okay. Let us keep it dotted as it is. Next, B. B is negative. So usually what is positive B? This way, right? So negative B means this way. So it is going to be in this way. Okay. Now again draw the resultant for this. So your resultant is going to be this, and the angle between these two is obviously 60 degrees. So you have the same scenario again, like you have one positive component, one negative component, again 0. So again angle is also 60. So again obviously in this case also you'll have the resultant as what? 3 by 2 phi m only. So the resultant will be the same again. Okay. Now let us do our last case, case 4. Where omega t is equal to 180 degrees. Okay. So in case of 180, what will be your phi r? Again, phi m sine omega t, right? So which is equal to phi m sine 180, which is nothing but 0. Next, your phi y will be how much? Phi m sine omega t minus 120. Omega t is 180. 180 minus 120 is 60, which is equal to root 3 by 2 phi m. Next, phi b will be equal to how much? Phi m sine omega t minus 240, right? Omega t is 120. So 180. 180 minus 240 is how much? Minus 60, which is minus root 3 by 2 phi m. Okay. Now again, same drill. Draw again. First, let us see what the resultant will be. So resultant will be also the same again, because you have one zero component, one positive component, one negative component, and again the angle will be 60. So okay, first let's draw the phasor diagram. Then you will understand if the angle is 60 or not. So again, in general it is like this, R, Y, B. So R is 0, so you don't need R component at all. Okay. Next, Y is root 3 by 2. So Y is positive. So you'll get in this way. And B is negative. Negative B means positive B is this way. Negative B means this way, right? So this way you will get. Okay. Again, if you do this thing, okay. So this is the resultant and the angle is again 60 degrees. Okay. So since the angle is 60, positive, negative, all the combinations are same again. So you will do 3 by 2 phi m again. This you will get the same value again. Okay. So now you said rotating magnetic field, but you're telling some derivations. If that is your question, now let us go back and see each case. In case 1, what is the direction of our resultant? Like this. Okay. In case 2, what is the direction of our resultant? Like this. So it is actually like this. From this, it became this. That means it used to be like this, but now it became like this, right? Now, okay, simple. See, it used to be like this. Now it became like this in this case. Okay, it was like this in case 1. Okay, in case 2, it became like this. Okay, now remember the same. In case 2, it is like this, right? Let us bring the same here. This is the case 3, right? So in case 2 it was like this. So in case 3 how it became? Like this. Okay, in case 3 this one, and come to case 4 it was like this in case 3, right? In case 4 it became like this. Okay, so what are you observing from these two things? This is case 1, this is case 2, this is case 4, the final one. So it started like this and it came like this. So that means as you continue, as you change omega t, it will keep on rotating. Okay, like this a rotating magnetic field will be generated. Okay, and at every point what will be the total resultant magnetic field? 3 by 2 phi m only, because in every scenario we are getting the same answer, right? So the resultant will be 3 by 2 phi m irrespective of the angle, and it will continuously keep rotating. Why? Because from here it became like this here, and from like this it became here, so it will be continuously rotating in this manner. Okay, this is how a rotating magnetic field will be generated. Got it? So yeah, that's all for this video, guys. I hope you guys understood. So this is for this video. If you have any questions or if you did not understand any part, let me know in the comment section. I'll try to explain it again for you. Thanks for watching the video till the end. Let's meet up soon in the next coming video with another topic. Thank you.